Heat treating is the soul of the blade. It's the process of hardening the steel so that it will both take and hold an effective cutting edge. The fundamentals of this require heating the steel to its critical temperature and then dropping that temperature to a specific degree in a specific amount of time, depending on the type of steel you're using. This shocks the molecular structure of the steel to convert from a larger grained structure called austenite into a more tightly packed needle-like structure called martensite. Even for similar types of steel, the exact methods and techniques of heat treating will vary from maker to maker. The more accurate you are with the control of the temperature, the more easily you can achieve the maximum potential of the steel. The method I'll be demonstrating with the two knives in this video is generally the same method taught at the Bill Moran School of Bladesmithing in Old Washington, Arkansas. It's a basic yet highly effective method for heat treating most high-carbon forging steels. It can also be done at a fraction of the cost of purchasing a computer-controlled heat treating oven. You want to take care of any jimping or hand file work on the spine of the blade before you perform the heat treat. This task is much easier while the steel is soft. Most forging steels are oil hardening. For this demonstration, I've used generic transmission fluid in a common turkey deep fryer. A good thermometer will ensure the oil is heated to the proper temperature. Once the oil has been heated, I use an oxyacetylene torch to heat the blade. For the Deimos, I harden the tail fin as well as the edge. A trained smith can judge the temperature of a steel by its color and by knowing what type of steel it is. An important factor in using a torch is to keep the color change as even as possible along the edge, and that the edge is kept at critical temperature for as short of a time as possible before quenching. This will ensure that both the edge is evenly hardened and that the steel doesn't burn and bubble. At this point, the steel is at its absolute hardest, but also its most brittle stage. The stress in the blade must be relieved through tempering in an enclosed oven. The more accurate the oven, the better, although this can easily be achieved in a common home oven as well. The blade should be a light straw color after having its temperature slowly brought up to between 375 and 425 degrees Fahrenheit, depending on the steel. To ensure a proper differential heat treatment, I further soften the spine of the blade to provide more flexibility and durability. The hardened edge is placed in a pan of water, and I use a torch to heat and draw the colors along the spine. Care must be taken to ensure that the edge does not heat up. The blades are now ready to have their top clips ground in. If using a non-variable speed grinder, make sure that the blade is dunked in water frequently during this process so that the tip of the blade does not heat up and soften. A good 8-inch wheel attachment on the grinder is perfect for grinding in clips. I clean up the coarse grit lines with a small flap wheel and then move to hand sanding. I sand all of my blades to at least a 400 grit satin finish. Once the desired finish has been achieved, I cover the blade in electrical tape to prevent scratches and scuffs while I'm working on the rest of it. Now the blade is ready for a handle.